Welcome to this video presentation by the postgraduate student whose poster it represents. We will miss the bustling crowds around the posters at the All Energy Conference this year, but we hope you enjoyed this online version that we have created. Before the presentation starts, I would like to acknowledge the support of our generous sponsors. Without this support, the competition could not proceed and the winning entrants would not receive a financial award. Our platinum sponsor is the Victorian Government through the Department of Environment, Land, Water and Planning. Its brands include Victorian Energy Compare, Victorian Energy Saver, Victorian Energy Upgrade Program, Energy Scorecard and Energy for Business. Their contact details are on the slide. Monash University's Monash Energy Institute is one of our silver sponsors. With over 170 staff involved, the Institute has a vision to bring people together to solve global energy problems. The Monash student posters in this competition represent some of that work. Baywa Renewable Energy is another silver sponsor. Baywa develops both wind and solar projects in Australia as part of a global energy portfolio. Baywa staff have also supported our AIE events in the past, including our Young Energy Professionals Speed Networking events. Our final silver sponsor is the University of Melbourne's Melbourne Energy Institute. Many of you will have attended their regular forums that keep the energy community and public up to date on technical and policy energy matters, and the University of Melbourne posters in this competition reflect some of that work. Seed Advisory is our bronze sponsor, and this small but well-recognised energy consultancy covers both the technical and regulatory fields. Seed Advisory has been a regular supporter of the AIE and a presenter at our events. Lastly, we thank All Energy for hosting our live poster events over the last decade, and we look forward to doing this again post-COVID. These last slides show you our poster winners in the last competition. And I now hand you over to the poster presentation. Thank you.
Good day everyone, welcome to my presentation. My name is Tanvir and I'm a PhD student at Monash University. The title of my presentation is Effect of Potassium Loss on the Biomass as Slagging Propensity and Bio-slag Flowability under Mild Reducing Environment. Let's start with the introduction. One of the most mature methods of energy conversion from biomass is combustion and gasification. However, this process inherits a problem. During the combustion and gasification, the ash generated during this process melt partially or fully and form slagging. So there are several adverse effects of this slagging. Actually, they corrode the gasifier, causes mechanical and failure, corrosion. They corrode the gasifier's wall, crack the reflector writing, and increase the maintenance costs. In case you are wondering what is the main cause of this slagging, so the vaporization of alkali and alkaline compound is a major problem that causes this slagging. For operating and designing purpose of boiler and gasifier, it is very critical to understand the emission characteristics of this alkali and alkaline. Unfortunately, the understanding concerning this alkali and alkaline emission out of bioslag is very limited at present. Most of the available information currently are quantitative rather than qualitative. Thus, in this study, effort was made to understand the influence of potassium loss on the bioslag propensity and flowability. This slide shows the composition of the ash we have used for this study, also the ash fusion temperature and V/A ratio of each ash. This slide shows the horizontal furnace that we use for our experiment. We use around 300 milligram of ash for our experiment, and during experiments we maintained a reducing environment. What we usually observe during gasification or combustion. This slide shows our experimental results. So only bioash 3 and 4 actually melted during 1400 degrees Celsius temperature, which can be justified by the ash fusion temperature. And also, if you look at the B over A ratio, the ash with higher B over A ratio flowed better. So this slide shows the relationship between B over A ratio with slag travel length and mass loss. If we look at the experimental result, we can see that ash with high B over A ratio actually travel better rather than the lower B over A ratio. Also same for ash with high B over O ratio has higher mass loss. Also they are highly influenced by the temperature as well. Because ash flowed better among these ashes, later we worked on the ash floors. So this result is for bioash 4 at different temperature. If we look at different temperature results, we can see that with increasing temperature, the potassium loss actually increased, which is actually kind of predicted because we expect that with increasing, more loss will take place. Then we conducted experiment at different inclination angle and time. Our result shows that time has no influence on the potassium loss. Rather, the inclination angle is more relevant or has more effect on the potassium loss. If we look at the result, we can see that high inclination angle has less loss, whereas low inclination angle has a higher loss. This is because of the corrosive nature of the bioash. At low inclination angle, they start corroding the plate. As a result, higher K loss take place. Whereas at higher inclination angle, they do not get a chance to corrode the plate. Thus, higher amount of potassium stay in the slag. And when we actually check the result for different inclination for same time, we also found the similar result, that we have less loss at high inclination angle compared to the high loss. And this can be actually proved by the result of elemental mapping. We can see that at 25 degrees Celsius temperature, an intrusion of aluminum take place from bioslag from plate to the bioslag, whereas intrusion of silicon take place from slag to the bioash. Also, this corundum plate, here we can see the corrosion that takes place during this time. Then, to know the effect of this KOH further, we conducted experiment by adding KOH additive and KCl additive at different amount. Our result shows that when we added KOH, the bioslag flowability actually increased, whereas when we add the KCl, they didn't affect the bioslag flowability. What might be reason behind this? So we did elemental mapping, SEM ADS analysis. When we did SEM ADS analysis, we found that when we added KCl, most of them actually they vaporized rather than staying in the slag, whereas when we added them in the form of potassium, they stayed in the slag and enhanced the slag flowability. And the higher amount of potassium stay can be proved by this elemental mapping. So we can see that we have high amount of potassium here rather, and whereas it didn't stay for the KCl. So the key conclusion came from this study are slag travel length and mass loss are highly influenced by the V over ratio of bioash. Inclination angle plays a significant role in the release behavior of potassium. At low inclination angle, they start corroding the plate. As a result, higher K loss take place. However, at higher inclination angle, they do not get a chance to corrode the plate. For bioash 4 and similar ashes, if more than 70% of potassium remain in the slag, they will enhance the flowability, whereas for bioash 4 or similar ashes are not suitable for combustion because of their high slagging tendency. However, they are suitable for indifferent flow gasification, where we expect actually slagging. Thank you very much.